Okay, let's talk about fundamentals of probability. So when it comes to probabilities, we have this range from 0 to 1. If an event has a probability of 0, it's impossible to happen. If it has a probability of 1, it is certain 100% to occur. Now we have this range in between. In the middle, we have 50% or 1/2. And then as we go up, the event becomes more likely, and as we go down, it becomes more unlikely. Some terminology we're going to use. We have an experiment, okay, where we don't know what the possible outcome is going to be. The sample space is the set of all possible outcomes in the experiment. And this is why we looked at the fundamental counting principle in the previous lecture. The event is the subset of a sample space, so it's a one possible outcome. The sum of the theoretical probabilities of all possible outcomes is 1, which makes sense. If you put together all possible outcomes, it's eventually going to be 1 or 100%. Now, the textbook has this formula for probability. Now, in true textbook fashion, they've overcomplicated something that's very simple. Here's what I want you to think about. The probability of an event. So the probability of some event E. Number of outcomes over the total number of possible outcomes. That's fine. A simpler way to think of this is simply part over total. If we talk about something very simple, like the probability of getting tails on a coin toss. How many possible outcomes are there? 2, either heads or tails. How many outcomes do you want? 1, which is tails. And this is all you have to remember, is that part over total for probability. Now, this is a ratio, which is fine. You could also turn this to a decimal, 0.5, or a percent, 50%. Okay, so they have an example here. A die is rolled once. Find the probability of rolling A, a 3, B, an even number. All right. Again, we just need to simply use part over total. If we're talking about a die that has 6 sides, 1, 2, 3, 4, 5, and 6, that is the sample space. That's all possible outcomes. The probability of rolling a 3. Be careful here. The temptation is to want to use the number 3. However, what you should think about is that 3 represents one side of the die. So there are 6 total outcomes. There's only one possible outcome that you want, and that's to roll a 3. For the probability of an even number, again, the total is 6, but there are 1, 2, 3 outcomes that are even, so we have 3 over 6, which is the same as 1/2. Now, this next example, we're looking at a deck of cards. Standard 52 card deck. Find the probability of getting a king or a heart. Just like in the previous example, simply do part over total. There are 52 total cards. How many kings are there? 4. 4 out of 52, which is the same as 1 out of 13. For a heart, there are 52 total cards. There are 13 total hearts, which makes 1 out of 4. Now that makes perfect sense. There's only 4 suits in the decks: hearts, diamonds, spades, and what am I missing? Anyway, all right. So if we go back to the text, clubs is the one I was thinking of. There we go. Okay, empirical probability. This is when we observe the number of outcomes and we compute. Now, don't get scared by this formula. It still represents the same thing. It's still part over total. So here we have this table. We have men and women, married, never married, divorced, and widowed. If one person is selected from the population at random, find the probability that the person is female. Okay. So if we go to the table, the part is going to be the total number of females, which is 124, over the total number of people in the study, which is 242. So 0.51, which makes perfect sense. About half are female. And we're done.